Hello, this video will be going through question by question for the try yourself on chemical formulas. So feel free to skip ahead, there will be a timestamp provided for the video below, and feel free to skip ahead to the question that you got wrong. Okay, let me go through the questions now. So first question, iron 2 sulfide. So take note that it ends with IDE, which means it is sulfur forming an ion by itself. Okay, then iron, Fe. Now, let's try and find these two elements in the periodic table. Iron is over here, sulfur is over here. We know that iron is a transition metal, and for a transition metal, there's no group number. I can't tell how many valence electron it has, so therefore I depend on these brackets to tell me what is the charge. So it tells me that it is 2 plus. For sulfur, it forms sulfide ion. It is in group 6, and I know that it has 6 valence electron. Okay, 2, 8, 6. For it to gain the noble gas structure, it needs to gain 2 electrons to have 8 outer electrons. Okay, so therefore, since it gained 2 negative electrons, it will have a charge of 2 minus. Now, let's see if the charges balance. One is 2 plus, one is 2 minus. Hence, they perfectly balance each other, and the formula is just FeS, present in a 1:1 ratio. Question 2 on zinc chloride. So let's look at the periodic table again. Zinc can be found over here, and chloride is found here. Okay, so we see that again zinc is a transition metal, but this time they did not provide the brackets to tell me what charge it is. So zinc is one of the cases where I have to memorize along with silver. Zinc typically forms zinc 2 plus, while silver forms Ag plus. Okay, so I know that zinc is zinc 2 plus. And chlorine is over here in group 7. So 7 valence electron. I need to gain 1 electron for it to obtain stable noble gas configuration, and hence chlorine would form chloride with 1 negative charge. Let's look at the charges. Are they balanced? 1 2 plus and 1 is 1 minus. So therefore, for every zinc which is 2 positive, I need 2 of chloride to balance the charges. Hence, the formula is zinc chloride, and there must be 2 chlorides. Note that this number, the subscript, only belongs to the element immediately before it, which in this case is chlorine. Next, we have carbon monoxide. So let's try and identify carbon and oxygen. Carbon is here, oxygen is here. We can see that they both are on the non-metal side of things. Okay? So because they are both non-metals, we know that this is covalent bonding. And for covalent bonding, it's actually very simple to write the formula. We just need to look at how it's written. So first, I have carbon, and then I have monoxide. So oxygen, and how many oxygen? 1 of it. So therefore, I just need to write C with 1 O, and that's the formula. Okay, next, magnesium hydroxide. Let's look at the periodic table again. Magnesium is over here. Hydroxide can't be found on the periodic table. Okay, it is a polyatomic ion, which is an ion that has more than 1 atom. So you just need to memorize hydroxide ion has the formula of OH minus. Then we look at magnesium. It's in group 2, so it is 282. For it to obtain noble gas configuration, must lose 2 electrons. So if magnesium were to lose 2 negative electrons, it becomes 2 positive. Hydroxide is OH minus. So if you look at the charges, one is 2 plus, one is 1 minus. How do I make them balance? I'll need to multiply hydroxide by 2. So the formula will be Mg OH bracket 2. Now, a common error that student will have is to write MgOH with a 2 behind here. What is the difference between these two? Okay, let's count what are the atoms present. So for the first case on the left, I have 1 magnesium. And can you see the 2 will multiply in to give me 2O and 2H. Now, if I go back to the original intent, which is that I must have 2 hydroxide ions to balance 1 magnesium 2 plus, how many O and how many H should there be? Okay, there will be 1 Mg, and there will be 2 hydroxide ions, which means 2O and 2H. And this satisfies that. Okay, let's look at the second example. Mg, there's 1 Mg. In this case, there's only 1 O because, as I mentioned, the subscript 2 only belongs to the element directly before it. Okay, so there's 2H. So we can see that over here, this part is different. Okay, so this formula is wrong. If you were to apply this, if you were to write this as the formula and you're calculating the MR, you'll get the wrong MR. Okay, so this is 2. For polyatomic ions, where we have to multiply them, make sure to bracket the entire polyatomic ion and put the subscript behind the brackets. Next, lead-2 nitride. Again, it is with an IDE, so it's the element forming an ion by itself. And lead is Pb, and then let's look at where they are on the periodic table. Lead can be found here and nitride here. Okay, so lead belongs in group 4, which we typically say do not form ions, right? But we notice that lead is down far below enough that it is very clearly a metal, and it actually tends to form an ion of charge 2 plus, and that is written here. Okay, again, there's a bracket here, so you just follow the bracket, lead 2 plus. Nitrogen is in group 5, so 2.5. I must gain 3 electrons to have 8 outermost electron, and hence it is N3 minus. So how do I balance the charges? One is 3 plus, one is 2 minus. This is where the concept of lowest common multiple comes in. 2 and 3, their lowest common multiple is 6. Hence, lead I need 2 times 3, and nitrogen I need 2 times 2. Okay, together they will form 6 positive charge and 6 negative charges. So how do I write it down in my formula? Oh, I should use red color. Okay, Pb times 3 and N times 2. Okay, so that's the formula for lead nitride, lead-2 nitride. Next, ammonium carbonate. This time, both the cation ion and the anion ion are polyatomic ions. So, for these two, there's no choice but to memorize them. Ammonium ion is NH4+, while carbonate is CO3 2-. If I were to look at the charges, I can see that to balance the charge, I need to multiply by 2 here. Okay, so again, how do I multiply by 2? I need to write that ammonium, then I need to bracket the whole thing, since it's a polyatomic ion, multiply by 2. Then I add on carbonate, there's only 1, so I just need to write CO3. Next, hydrogen. Recall that we mentioned that hydrogen is one of the elements that will exist as a diatomic molecule. That is to say, it will exist as H2. That's it. Next, calcium. Now, if it's not stated that it's a calcium ion, calcium by itself exists as a metal. And for metals, we just need to write their formula as per their chemical symbol, Ca. Don't need to write any charge. unless it's stated that it's a ion. Next, going on to the right hand side, let me just move this. Ammonia is not on the periodic table. It is a covalent molecule whose formula you need to memorize. Take note of ammonia versus ammonium. Okay, how I remember is their difference is 1H plus. Okay, so this is NH3 and ammonium is NH4 plus. They differ by a H plus. Next, calcium hydroxide. Again, hydroxide is a polyatomic ion. To memorize it as OH minus. Whereas calcium can be found here. With 20 electrons, it is 2882. Okay, so 2 valence electron to attain stable noble gas configuration must lose 2 valence electron, and calcium losing 2 negative electron forms 2 positive charge. How do I balance this? 2 plus 1 minus, so therefore it is Ca, then hydroxide mass times 2, OH whole thing bracket times 2. Aluminium sulfate. Now this time we know that it is ATE, hence it is the polyatomic ion SO4 2 minus to be memorized. Okay, whereas aluminium, we can see that aluminium is over here. Aluminium is over here. Right, it's in group 3 and hence it has 3 valence electron, 283. Okay, so how does it obtain noble gas configuration? It must lose 3 valence electron. Okay, if it loses 3 negative electrons, it is 3 positive. Again, I have a 3 plus and a 2 minus, so how do I balance it? Must make it 6 again, so times 2 times 3. How do I multiply by that? Aluminium, then add a subscript 2, sulfate, SO4, then whole thing bracket and multiply by 3. Next, potassium phosphate. Okay, potassium phosphate is a polyatomic ion that has to be memorized. Okay, actually for your syllabus, you don't need to memorize this, but I've given it to you. Okay, so it's PO4 3 minus, and potassium can be found here. 2881 to form 19. So to obtain noble gas structure, lose that 1 electron and it will be K plus. Then I have a 3 minus, 1 plus, so I must multiply the plus by 3. So the formula is therefore K first. Notice that cation ion always comes first. K3, then there's just 1 phosphate, PO4. That's the end. Methane is another formula that you have to memorize. That's CH4. You can also deduce it yourself if you know that methane is made out of carbon and hydrogen. Carbon is found here. Okay, let me just erase the previous one. Carbon is found here and it is 2.4. It needs 4 more electrons, right, to obtain noble gas configuration. Hydrogen just has 1. So the first shell only needs 2 to obtain a fully filled outer shell, right? So it needs 1. This one needs 4. So if they need to share electron, each carbon must find 4 hydrogen to share 1 electron with each. Okay, I say again. Each carbon must find 1 hydrogen, because each hydrogen only got 1 electron, right? Carbon needs 4 more, so you will need to find 4 hydrogen and each to share 1 pair of electron. In total, this will give carbon 8, and each hydrogen will have 2. So that's how you can deduce methane yourself. Next, phosphorus trichloride. Okay, if we look here, we can see that phosphorus is over here and chlorine is over here. Both of them are non-metals, so this is a covalent molecule. And covalent molecule just need to follow the name. Okay, so phosphorus, P, and then chlorine, there's 3 of it. That's all. Next, sodium nitrate, ends with a ATE. This is a polyatomic ion between nitrogen and oxygen. NO3, 1 minus, to be memorized. Sodium can be found over here. It's in group 1. 281 will lose 1 electron to form Na+. Okay, then let's look at their charges. 1 plus, 1 minus. Hence, the formula is just NaNO3, since they balance each other already. Last question. I have magnesium sulfate. Again, sulfate ends with ATE, means it's a polyatomic ion. Magnesium is over here, so that's 282. You will need to lose 2 valence electron, so it forms Mg2+. Sulfate is a polyatomic ion between sulfur and oxygen. SO what? SO4, 2 minus. Look at their charges. This 2 plus, 2 minus. Hence, it is MgSO4. Okay, so that's it for this short exercise on chemical formulas.